So I thought I'd show you how to do this problem with using that David Lane applet or an inverse normal feature, because Dr. Stevens certainly walked you through how you do it with z-scores. So what I'm seeing is that I know these potatoes will have a mean of 8, a standard deviation of 1.2, and I want to know what weight marks off the bottom of the top 20%. It's the heaviest 20%, so that means they're the heaviest. So we're all looking at the right area. So I've got this linked in a couple of different places in the course, but if you can't find those links, or you're in a hurry and you don't want to go back logging in to find it, if you just Google David Lane normal, it's this top hit. Make sure you include normal, because David Lane was also there's a guy named David Lane who was a white supremacist who died in prison. He was a miserable guy. But we don't want to look at his stuff. We want to use his calculator. So make sure to include the word normal. And they give us a little nice sketch, and all this asks you to do. You don't have to do z-scores, though you can. It'll work with z-scores, but we don't have to. Let's see, what was the mean? I think it was 8. Yeah, 8. So the mean was 8. The standard deviation for these is 1.2. And we want to know, oh, I'm sorry, I got to do value from an area. That's what I want. We know the area. We know the top area is 20%. So I'm going to change that to be 0.2. Notice the way it shades it in. And now we're going to give it the mean and the standard deviation. And we want, let's see, above it. Yes, that's right. So 9.01 is the number that cuts off the top 20%. So minimum weight, he needs to buy potatoes that will weigh 9.01 or heavier. Now, what if he wants to use the lightest potatoes for a potato cannon? So that's the bottom 5%. So we're going to change the area to 0.05. Same mean, same standard deviation. We want to go below. And there's the not the z-score, sorry. That's the weight that demarks the bottom 5% of all potatoes. Okay, a little bit easier than using z-scores in the table. I mean, not that that's that hard, but this is pretty slick. Then we want to find determine the weights that delineate the middle 90%. So if we come back to that applet, and we're going to go between, actually let's change the area to 90%, so 0.9. And we want to go between and see the way it gives us that nice graph. And there's the numbers. The bottom number, so 90% of the potatoes will weigh between 6.026 and between 9.974. Typically, this will be give you enough decimal places to make WebAssign happy. Sometimes MyOpenMath is looking for a few more, and this won't always do that. Usually it will. For the most part, it will, but sometimes if you're going to use this from MyOpenMath, we got to be a little selective in what we pick. Okay, so hopefully this helps you out. There.